Hey everyone, and welcome. Have you ever wondered how an AI can read a sentence and just get it? Like how it actually understands the context and the meaning behind the words? Well, today we're going to pull back the curtain on one of the coolest ideas in all of modern AI, the attention mechanism. All right, so let's just dive right in. For us, understanding language is just second nature. But for a computer, it is a massive, massive challenge. Let's take a look at a really simple sentence that kind of shows you just how tricky this whole thing can be. So when you read this, what does it refer to? Well, the animal, right? Obviously. A street can't be tired. But what if we change just one single word? What if the sentence was, because it was too narrow? All of a sudden, it flips and points to the streets. That little switch, that's context. And teaching a machine to see that difference is the entire breakthrough. So how do they do it? Well, the solution is this really elegant system called the attention mechanism. And honestly, the best way to get your head around it is to think of it like a super smart library database. It all works with three core concepts: a query, a key, and a value. Okay, so first up, we have the query. The query is just what you're looking for. It's the question you're asking. In our sentence, the word it is our query. The AI is basically asking, hey, what on earth is this it thing referring to? I need more info. Next up, you've got the keys. Now, the keys are all the possible answers in the sentence. Think of them like the titles on the spines of all the books in that library. For us, the words animal and street are the keys. They're the options the AI can choose from. And finally, there's the value. The value is the good stuff, the actual meaning and context inside the book. So once your query finds the right key, you get to unlock its value. The value is the rich, detailed meaning of animal or street. So it really all boils down to this one simple mantra. Just remember this. The query is what I want. I want to know the meaning of it. It scans all the available keys, which are what I offer. In this case, animal and street. And when it finds the best match, it pulls out the value, which is what I have, the full, rich meaning of that word. Okay, so that's the big idea, but how does a machine actually choose the right key? It doesn't have gut feelings or intuition. What it has is math. So let's take a look at how this actually works under the hood and break down the simple calculations that drive this whole thing. It's really just a straightforward three-step recipe. First, the AI turns words into lists of numbers, which we call vectors. Then it calculates a match score between its question, the query, and each possible answer, the keys. And finally, it turns those scores into simple percentages so it can make a clear choice. Step one is all about translation. You can't do math on words like animal, but you can totally do math on numbers. So every word gets converted into a vector, which is just a list of numbers that captures its essence. An animal, for instance, would get a high score for biological and for state of being, because, it's alive and it can feel tired. A street, not so much. And that brings us to the actual matching part. The AI takes the vector for its query, it, and it basically multiplies it with the vector for each of the keys, animal and street. This calculation is called a dot product, and all it does is spit out a single number that tells you how well they match up. It's a relevance score. And here's where the magic happens. Look at this. Because the context is tired, the query vector for it is searching for something that's biological and can have a state of being. So when it multiplies with animal, bam, it gets a high score of 2.0. But with street, the score is a measly 0.2. The math has found the link. I mean, just look at it visually. It's not even a contest, right? The connection, the alignment between it and animal is 10 times stronger than the one with street. The numbers are screaming the answer. But, a raw score isn't a final answer. The machine needs to make a firm decision. So it uses one last little math trick called softmax. All this does is take those messy scores, 2.0 and 0.2, and turn them into clean, easy-to-understand probabilities that add up to 100%. And there you have it. The model decides to pay over 90% of its attention to animal. This isn't a wild guess. It's a confident choice, calculated based on the mathematical relationships it found in the sentence. That right there is how a machine pays attention. But what happens when a sentence is way more complicated? What if a single point of view just isn't enough to figure it out? Well, that's where this system gets a serious upgrade.
So instead of just relying on one attention calculation, the really powerful models use something called multi-head attention. And you can think of this like having a whole team of specialists, all reading the sentence at the same time, but each one is looking for something different.
So you might have one head that's a grammar nerd, and its whole job is to connect the pronoun it to the noun animal. At the exact same time, another head is the context expert, and it's linking it to the adjective tired. When they all put their findings together, they build this incredibly rich and deep understanding of the sentence.
Now, this amazing skill, this ability to understand context, is the absolute heart of models like ChatGPT. But all of this power, it comes with a catch, a really, really high computational cost. Here's the problem. The number of calculations grows exponentially. So for a tiny sentence with, say, 10 words, the AI has to compare every word with every other word. That's 10 times 10, so 100 calculations. Totally doable.
But what if you ask it to read a book? A book with 100,000 words? Well, that number just explodes. It's 100,000 squared, which comes out to 10 times billion calculations. The cost just becomes astronomical. And this right here explains a limitation you've probably run into yourself: the context window. It's the reason a chatbot can start to forget what you were talking about at the beginning of a really long conversation. There's a hard limit to how many of these billions of calculations it can actually handle at one time.
So making this whole attention process more efficient is one of the single biggest challenges in AI research today. And as we wrap up, it leaves us with a really fascinating question to think about. If we could crack that efficiency problem, what's the first huge and possibly large text you'd want an AI to read and understand for us? All of medical history? Every legal document ever written? The possibilities are just staggering.